Hello everyone and thanks for watching. In the next few minutes I'm going to teach you everything you need to know about CodeBlocks. So the first thing you're going to want to do is give yourself all the necessary blocks. And you can see here I've already typed in /cb help, which displays the help menu. And the command to give you the necessary blocks is cb blocks. So after you type that in, you'll see that you're given all of the blocks related to CodeBlocks. So we got the robot, these green ones here, move the robot. So we got forward, back, turn left, turn right, ascend and descend, which move the robot up and down vertically. We also have a sense block, which you can use to ask the robot which block is in front of it. A build block, which you can use to command the robot to construct things for you. We have a sign, which we'll need later, a function block, dig below, dig in front, and harvest. Now you'll notice that I skipped some of the blocks, but those are ones that aren't going to be too relevant for you, so I'm going to leave them out of this tutorial. The first thing we need to do is define a program. And to do that, you use a sign, and you place the sign on the ground, and we have to give this program a name. So on this sign, the first line of the sign needs to read the word program, and the second line needs to read the name of the program. And here I'm going to name my program test. The next thing we need to do is determine which direction we're facing. And we can do that using the command /cb compass. So here I'm facing west, and what I need to do is face to the south. So now that I'm facing to the south, I can start to begin to build my program. And the way we do that is by placing a line of blocks in a row to the south of the sign that defines the program. So here I've created a program that moves the robot forward 4 times. To run this program, you type the command /cb run and then the name of the program. So here the name of the program is test, so the complete command is cb run test. You'll notice that it gave me an error message indicating that the robot has not been placed. And what that means is that you haven't yet placed the robot into the world, so the program can't be executed. So the robot is the red block. You'll see that it's kind of got a little face, and once you place it into the world, it's going to face in the same direction that you're facing. So here I was facing to the south, so the robot's facing to the south. If instead I'm facing to the west, the robot is going to face to the west. So if I place the robot down, and again tell the system to run the command, you'll see the robot move forward 4 times. Now you should also notice the white block with the purple arrow on it. As you run your program, you're going to see that block move within your program. That block is used to help you debug your programs, and it indicates which action the robot is currently executing. The program is going to execute the actions in the order you place them, and each time you run the program, it's going to reevaluate the actions that are placed there. So if I go ahead and adjust the program, you'll see that the actions executed by the robot are reflected in the changes that I just made. So the next thing I want to show you is how to use sense blocks. So sense blocks are used to have the robot perform one set of actions if the block in front of it matches the block we ask it for, and a different set of actions if the block is not found. So here I'm going to create a second program, call it sense, and I'm going to ask the robot to look at the block in front of it, and if it finds the dirt block, I'm going to have it jump over the dirt block, otherwise it's just going to move forward. So you'll see when I place this sense block that a set of colored squares appeared. And these red and green squares are here to help you remember where your action should go to determine which set of actions the robot should perform. So with the sense block, you need to place a sign on top which indicates which block the robot should look for. So I'm going to ask the robot to sense for a dirt block. If it does see a dirt block in front of it, it's going to execute actions placed on these two green arrows and continuing in a line. So here I want the robot to kind of jump over the dirt block. So I'm going to have it, let's see, need to ascend. So it's going to move up, forward twice to get over it, and then I'll have it move back down. And if instead the robot does not sense a dirt block, I just want it to move forward. So here we go. I'll place the robot and run the program. So because it did sense the dirt block, it executed the actions that I placed on top of the green squares. And now if I run the program a second time without a dirt block in front of the robot, you'll see that it just moved forward instead. So this is kind of a simple example, but later on I'm going to show you something a little bit more complex that uses sensing to make a more efficient program. Before we go on to the next section, I just want to show you some functionality that you can use in case you need to edit your program, but it's a little bit more built than what I've got here. So say for example that I wanted the robot to turn to the right 4 times before it sensed for the dirt block. Now instead of just destroying all of these blocks and then rebuilding it from scratch, there are 2 commands that I can use to insert new blocks into a program. And those commands are shift and unshift. So here I know that I want to place 4 turn right blocks in between the forward and the sense. So what I need to do is shift the sense block and its row by 4. Oops. So the command is shift and then a number. So here I've placed the 4, so it's going to shift that column of blocks 4 squares away from the start of the program, allowing me to place the 4 turn right blocks where I like them. Now you'll notice that this forward block is supposed to be over here next to that sense, but unfortunately the shift block is only going to shift 1 column. So I also have to shift the forward block by 4. Now let's say I made a mistake and I accidentally shifted a set of blocks more than I meant to. Or maybe I changed my mind and I only want 2 turn rights. So to get these blocks to move back adjacent to the rest of the actions, you can use the unshift command and again indicate how many blocks it should unshift. And then don't forget, if you've got actions placed next to a sense block, you have to unshift those as well. Unfortunately, I'm having some recording problems, so if you see me kind of fly around this environment or things appear and disappear, that's because I've had to re-record something, and so some things have changed. But what I want to add just to this shift stuff before I go on is that the blocks that you shift are determined by the location of your crosshair. So here with the crosshair on top of this up block, it's going to shift the up block and its connected blocks to the right. And again, so if I were to do it with this forward, it's going to shift the forward and the block is to its right. The same thing works with unshift. So looking at the up block, I unshifted twice. You'll see that only the up block was moved and the 2 forwards were not affected. That's because they weren't attached. So there was a gap between them. So the shift and unshift are only going to move groups of blocks. Alright, so the next thing I want to talk about are functions. And functions are a set of actions separate from your program. And we can use functions to tell the robot to repeat a set of actions. So here I'm going to create a second program. And let's have it move forward. And I'm going to create a function for this program. And so when we define a function, we need to associate it with a program. So the first line here indicates that this function belongs to test2. And now we need to give the function a name. So I'm going to call it the word blue. And let's have this function tell the robot to turn left twice. So to instruct the robot to perform a function, we need to use the white function block. And on top of the function block needs to be the name of the function. So here, the word blue. So now if I run the program, you'll see the robot moves forward and then performs all the actions in function blue. We can also, so as I mentioned before, we can use functions to repeat a set of actions. So I'm going to alter this function so that it tells the robot to move forward. And now I can use recursion to loop this function indefinitely. So if I define this function such that at the end of all of its actions, I instruct the robot to go back to the start of function, go back to the start of function blue, you'll see the robot move forward over and over again. And now, if you ever read a program that loops like this forever, you're going to need to be aware of two more commands to use. And so that are pause and stop. So pause tells the robot to stop executing, but it remembers where it was when it stopped. So if we use the command resume, the robot's going to pick up where it left off. If instead we use the action stop, the robot's going to stop executing, but it's going to forget where it was in its execution. So to start it back up again, we have to use the run command. And here, I'm not exactly sure why the sign disappeared when I ran the program, but you'll notice this error message. So you might see error messages every once in a while, and I've hopefully made them descriptive enough so you can see what's going on. So here, function test.blue is missing the sign above a function call. So the period kind of separates the program name of the function and then the function name. So here, the program name is test2 and the function is blue, so it's referring to this function here, and it's saying that on top of one of my function calls I'm missing a sign, and that is the case. So I'm going to replace it and then rerun the program. So although it may seem like recursive functions are going to loop forever, we can actually add sensing and only repeat if a condition is true. So here I'm going to add a sense block to this program so that the robot only moves forward as long as there's air in front of the robot. So here, telling the robot to sense for air. If you find air, then I want you to repeat the function. And if you don't find air, I want it to stop. So I'm going to leave the block above this red square empty. So here, I'll rerun the program. Oh, and I forgot to add something in front of the robot, so let's do that here. So see it's moving forward over and over again because there's air in front of the robot. But then this last time, when I ask it to sense for air, it's found the up block instead. So it's going to look for actions placed on top of this red square, but since there are none, it's going to stop. And this lack of a block doesn't actually tell the robot to exit the program. It tells it to leave the function that it's currently in. So if I were to rerun this, well, that's not going to work, and place some actions after the function call, you'll notice that when the robot runs into the up block, it leaves function blue and then continues executing to perform the two up actions. And now the last thing that I want to show you is how to call functions that belong to another program. So although every function needs to be associated with a program, you're not limited to the functions, or you're not limited to calling functions within the program. So I'm going to rewrite some of this here. So let's do this. So we'll change function blue so that it tells the robot to move up 3 times, and then let's change the program so that we call the function blue, and now we call a program or a function from another program. So earlier off camera I created this function. I'm actually going to rename it so it's a little more less ambiguous. So here this function belongs to program test, and the name of the function is red. So this function tells the robot to move down 3 times. And now to call that function, I need to indicate which program it belongs to, and also the name of the function. So essentially I'm writing the text that appears on the function sign in this function call. And you only have to do this if the function you're attempting to call does not belong to the program that the function call is in. So now if I rerun this program, you'll see that the robot performs function blue, so moves up 3 times, and then it performs function red down at the other end, which tells it to move down 3 times. So that's pretty much it for the things that you need to know to start building programs with CodeBlocks. But before I finish, I just want to show you some of the cool things you can do with building. So this is the build block. It's kind of the reddish with the grass block image on top of it. And this action tells the robot to place a block into the world. And it requires a sign on top, and the sign needs to indicate where the robot should place the block in relation to the robot. So our options are front, back, left, right, and top or bottom. And then the second line indicates which block the robot should place. So here I've written smooth brick, so it's going to build something that looks like this, and I'll show it to you in a second. And the other options for the block type are listed on the plugin page. So here I've created a program called tower and 2 functions. So the first function here I've named wall, and what that does is build a row of 4 smooth bricks. And then I've created another function called level, and that builds 4 walls. So the program is defined so that the robot builds a level, moves up, and then goes back to the beginning of the program. So it builds a level, moves up. So you're going to see this robot build this tower level by level. So if I go over here and place the robot, so you see the robot's moving pretty quickly. That's because I had an error in recording, so I've already built this over there. But we can change the speed of program execution. So that's with the command speed. So the default is 20, and that tells the robot to perform an action once every second. But any integer is valid as long as it's 1 or greater. So 1 tells the robot to perform an action 20 times a second. So the greater the number, the slower the execution. So I'm going to let this robot continue to build. And while it's doing that, I'm going to show you another program that I've created. So this one here, I've named Spiral, and what it does is build a spiral staircase inside of this tower. So the way I've defined it is that as long as the robot senses air in front of it, it's going to move up, build a stair below it, and then move forward, and then repeat the program. And if it doesn't sense air, so if it runs into a wall, it's going to place a regular brick below it, turn right, move forward, and then repeat the program. So let's get this tower a little bit taller and build an entryway. That's probably good enough. So place the robot here and then tell it to run the program. So slowed it down a little bit so you can see what goes on. So as long as there's air in front of it, it's going to build a staircase below it, and then when it runs into the wall, it's going to build a brick in that corner for you to stand on and then continue going. So we've got stairs and then a brick and then some stairs and then a brick. So we get this nice staircase inside of the tower that we just built. And so this is an example of kind of the time that you can save by using CodeBlocks. So here, you didn't see me build it, but it didn't take very long to build this program. I mean, it's only got 9 actions in it. But it saved me a lot of time that I would have otherwise spent building this spiral staircase. So that's it for this tutorial. Hopefully everything makes a little bit more sense now. So good luck building stuff with CodeBlocks.